Good everyone, we are all welcome. In today's session, we are going to dive into hypergeometric distribution. In our previous videos, we learned about binomial distribution and then we did Poisson distribution too as well. So today we are doing hypergeometric. And for hypergeometric, the number of samples will be given, unlike the Poisson that you don't know the sample size, but for hypergeometric, the sample size will be given. And then for hypergeometric, when a succession or when a sum of numbers are selected, they don't replace them back, unlike binomials where the successions that they will select runs for all probabilities. For hypergeometric, when they select a number, that number, they don't replace it back, right? Okay, so they said n trials is a sample taken from a finite population of size n. So sample taken without replacement. So when those samples, they don't replace them. Unlike the binomial that every samples no, we replace them or we use them again. For hypergeometric, when a number is taken, we don't replace them. And then the trials are dependent, they depend on their own. Concerned with finding the probability of x success in the sample where the x successes in the probability or in the population. So here is the case. You will be given a certain success, and out of that success, you have to find the probability of a certain success, right? So a scenario can be a population and you finding its perimeter. You understand? Yeah. Or its sample size, something like that. So within the success that will be selected, you have to find a particular number. So they will be given that will be given in the question, right? And that number that you are finding is not replaceable. Okay. So for hypergeometric distribution, this is the formula. They're saying that the probability of the sample selected is equal to the commutative of this n represent the population size minus this x, that is the sample that they will select, right? And then this n minus another x. This x is a subset of this big X. So imagine, let's assume this is the population size, and out of the population they said females. So this X, capital X or the big X represents females. And out of these females, they are saying that what's the probability that maybe 5 of them are females, right? So this is like a subset of this big X. Okay. And when we come to this commutative to talking about the selected X out of this subset. And then all over the commutation of n, that's the population size, minus the n, small n, which represents, let me say, the differences, right? The differences in the population, right? So here is the case where if the population, the overall population is 20, and then 10 are females. So they tell you that assuming 15 people are selected randomly, right? So that 15 people represent this 15. Now, as people selected randomly from this population, right? And then you subtracting x, that is the x will be how many females are from this number selected. So as we solve more examples, we got to understand. So they say n represent the population size. So this n, capital N, represent the population size. That's the overall population. This x represents the number of successes in the population. So this capital S represents the number of successes in the population, right? And this n represents the sample size. And the x represents the number of success in the sample size. So the number of success in the sample size. And n minus x is equal to the number of failure in the sample size. The number of failure in the sample. Alright, so this is the formula. Okay, so our commutation of our population size minus the number of success in the population, right? And this is our sample size minus the number of success in the sample size, in the sample. And then this represents the commutation of our number of success in the population over our number of success in the sample, all over commutation of the population over the sample size. So if I have to find the population of x, so we just represent, so this x represents the sample the number of success in the sample. Okay, so let's solve an example and we will understand. So example, the 3 bulbs were selected from 10. Out of the 10, there were 4 defective. What's the probability that 2 of the 3 selected are defective? So here they are saying that 3 bulbs were selected from 10. And out of these 10, there were 4 defective, right? And then what's the probability that 2 of the 3 selected are defective? So we know our total number of bulbs are 10, so represent it by n is equal to 10. And out of these 10, there are 4 that are defective, right? So these 4 represent the n. So we say our n, our x, sorry, our capital S is equal to 4. That's the defective bulbs. And then our sample size, the one selected, so which is 3, they were selected, and what's the probability that out of these 3, 2 are defective? So we just represent them like this. And then we know our formula, right? So we say probability of S is equal to 2, and we then put them in this formula. So we get 6 commutative 1, 4 commutative 2, out of 10 commutative 3, and then this is what we are going to get. So this 10 commutative 3, this 10 represents the total number of bulbs, and this 3 is a selective, right? That's the number of the sample size that was selected. This talks about the difference, and this talks about the succession. So if you can take good a perfect view, you could know that we were saying 4 were defective, so the 4 commutative, and they are asking that what's the probability that 2 of the 3 are defective. So 4 commutative 2, that's the number of bulbs that are defective commutative, the 2 that they are probably thinking they will be defective, right? And then the difference is 6 commutative 1. So this is success and this is failure, something like that. So that's succession and then the failure. And then we are saying that for hypergeometric, it's not replaceable. That's why we subtracted the 4 from this 10, that makes us 6 here. And then we subtracted the 2 from the 3, that makes us 1 here, right? So this is the formula. You just input the values, and then you have this. So this is the probability that 2 out of the 3 will be defective. I think that was the last example that they solved. So I have 2 examples here. Let's work on these ones, and then we call it a day. So it says local council consists of 12 members, 7 male, 7 men, and 5 women. A subcommittee of 4 members is to be formed by choosing members at random. 1. Okay, A. Calculate the probability that the subcommittee will consist of exactly 2 men and 2 women. And the second one to say, what's the probability that the subcommittee contain at least 3 women, right? So the council consists of 12 members, and out of these 12 members, they said 7 are men and 5 are women. So a committee of 4 members is to be formed by choosing members at random. So we should calculate the probability that the committee will consist of 2 men and 2 women. So let's write our solution here. So we know the number of samples is 12, so there are 12 members, so our capital N is 12, right? So we have 12 members here. And then we are saying that 7 are men and then 5 are women, right? So this man and then this woman, they represent the X, the big X. So let me write big X, but then let me bring 1 here. That's represent this for women, and then there are 7, there are 5 women. Let me write S2 for men, and there are 7, right? And he said a committee of 4 members is to be formed by choosing at random. So these 4 members become the sample that they are choosing, right? So this becomes our n. So our n is equal to 4. And then they are asking that out of this 4, we should calculate the probability that committee will consist of exactly two men and two women. So this one they share them together. So they are saying that exactly two men and two women. So that will be our small x. So let's make our small x1 to be the woman, right? So two men and then two men. So x22 will equal to 2. So now we have to bring our formula. What's the formula? How does it say? Okay. So this is the formula, right? We have to find the probability that exactly two are men and two are women. And then the sample selected was 4. So this is equal to our probability of so 2 men and then our x, our x2 is equal to 2 women, right? So this is equal to, and we are saying that our computation of n minus x, that's the population size minus the selected numbers, right? And then n minus x, and here the selected numbers, there are 7 men and then the 5 women. And out of those selected, they are saying that all the probability that exactly 2 are men and 2 are women, right? So we say our computation of our n minus x, and this is our n minus x. So this 2, but then it's 4 here. So we say the 12 minus the 4. So we put this one into brackets. Computation of our n minus x, and then our n, our small n is the 4, and our x2 is 4, right? So that's the 2, so it's 4. So we bring brackets open here, and then we have 4 minus our 4, it will give us 0. So the value of this one will be 1 because any number commutation 1 is 1. Any number commutation 0 is 1. So we multiply this by the success, right? Which we say 2 men and then 2 women. What's the probability for men? The 7, the number of men is 7. So here we have 7 commutative, and then I'm saying that 2, right? So this one to multiply by the number of women, which is 5. So 5 commutation, and then we are saying 2 out of the amount of probability that 2 are women, right? So all these over the number of commutation. So we have 12 commutation of n, which is 4, right? 12 commutation 4. And this is going to give us so this is the probability that exactly 2 men and 2 women is that we should calculate the probability that the subcommittee will consist of 2 men and 2 women. So this is the probability that 0.424 will be the probability that exactly 2 men and 2 women will consist of the subcommittees. So that's for A. So we are must solve for B. So for the B. So the B. And the B to they are asking that what's the probability that the subcommittee consists of at least 3 women. So here we are talking about only women. They are saying that at least, right? So you know the formula already. So we say our probability. So at least 3, which means it's greater than or equal to 3. So they are saying at least 3, right? So first of all, at least 3 means from 3 upwards. And we can't find a probability for each one. Therefore, we have to find a probability that um, there will be 0, there will be 1, there will be 2, and then we subtract it from 1. And then we get the probability that at least 3 of them are women, right? So we'll get like, will be like 1 minus the probability that x is equal to 1, x is equal to 0, plus the probability that x is equal to 1, plus the probability that x is equal to 2, right? So when we subtract this from 1, we are going to get the probability that x is less than x at least 3, right? X is greater than 3 or equal to 3. So just input the formula, right? We are saying that it's equal to 1 minus the probability that x is equal to 0. Question is not also anyway. I can better do it now. I try from my phone on my phone. Laptop is it anyway. So 5 women. So the commutation of lawyers before are selected, right? So we have 4 minus 0. So here is 0. And this multiplies the success, right? Which is we have 4 are selective, but then the commutation is 0. Okay. So the commutation of 12, 4. So plus the probability that is equal to 1, right? So let me copy this. And just bring it here and just change some couple of things. So here is one. Here is one. So same thing here. So you work on this one. We're going to get 1 minus. So you punch the computation of 0, computation of 1, probability of 0, probability of 1, probability of 2. So let me punch them. So when we add everything in the bracket here, we get. So this is the probability that the subcommittee consists of at least 3 women. So this is it. So let me explain it well for you. We said that the local council consists of 12 members, and we said our number of the total number is 12, so represented by n, capital N, which is 12. 7 of them are men and 5 are women. So the women, these are the women, and the 5 are women, and then 7 of them are men, right? And then they say the subcommittee of 4 members is to be formed by choosing random members at random. So these are the subcommittees, the 4 members. That's our n. It's supposed to be small n, right? So our small n is the 4 members. And they asked that we should calculate the probability that the subcommittee will consist of 2 men and 3 women, right? So out of the 4, they are saying we should find the probability that 2 of them will be men, 2 of them will be women. So this is the formula, the P of x, and the probability of x number of people is equal to this. Right? So this is the formula. So we just include them in the formula. So the probability that the men are 2 and the women 2 are 2, right? So the 12 computation of 12 minus 4, that's the n minus the x. So you can just write the answer instead of you writing 12 minus 4, right? But then for clarity's sake, I decided to write it here. So our 12 minus 4 commutation, 4 minus 4. The sample size or the subcommittees were 4. Now this and 4, right? And then we had 2, the probability that 2 are women and 2 are men. So summation of the women and men to make 4. So 4 minus 4, multiplying the 7 commutative 2, which is the probability for men, right? We have 7 men, so 7 commutative 2, that's the 7 men over the probability that 2 will be selected. Multiplying the 5 commutative 2, which is the probability of women, which is 5 commutative 2, which says that 2 of the 5 women will also be selected. Out of the total, there's the n over the n, right? So 12 commutative 4. The 12 is the total sample, and the 4 is the randomly selected members, right? The subcommittee members. Okay. So when you point this on the calculator, you get this. So that is it. And then the B was talking about what the probability that the committees contain at least 3 women. So they are saying that the women should be more than 3, right? So we say S is greater than 3 or equal to 3. And then if you want to find from 3 and above, even though they are 10, they are 10, they are 12 members. So it means you have to find the probability that 3 are women, 4 are women, 5 are women, 6 are women, like up to 12. That will be a lot of work. So what we are going to do is that we say 1 minus the probability that none of them are women, only 1 are women, or 2 are women, right? And then we sum them and we subtract from the 1. And this will yield us the same information as if you have to find from 3 and upwards. So we say 1 minus, and we fix them into the probability, the formula. This is n minus x computation n minus x. So we have the number was 12, then minus 5. Computation 4 minus 0, because we are finding probability of 0. Multiplying 5 commutative 0, right? That's the 5 succession over the sample, which is 0. Okay. So all these please represent this. So over the total sample, that was 12, over the selected ones, that was 4. The selected committees, the subcommittees, that was 4. But the probability of x is equal to 1. So we're just fixing the values alongside the formula. Then when we add them, when you point them on a calculator, this is what we are going to get for this, and for that. When you add them all, we get this and subtract from 1. And this is going to be the probability that at least 3 of them are women, right? So this is for Poisson distribution. There's another one question here, but then I would like you to solve it. Okay, try your hands on this.